Okay, in this video we're going to discuss one-to-one functions. If you remember way back to when you first learned about functions, you would often make these mapping diagrams to determine if something was a function or not. And the way that you would do that is you would look to see that an x did not give you two different y values. So we couldn't have like 2 going to 9 and also 2 going to 5 or something else like that, right? So an x value couldn't give you two different y's, and the problem with that is you would have something that would not pass the vertical line test, and therefore if it didn't pass the vertical line test, it wasn't a function. Okay. Well, now if we wanted to talk about if that function, so we're going to assume we're passing the vertical line test, if that function is a one-to-one function, that means that not only do the x's not repeat, but also the y's will not repeat as well. So example 1 here is not a one-to-one function because both 4 and 11 give me a y value of 5. Okay, so it's a function, but it's not one-to-one. So what you want to think of for a one-to-one function is every single x, which will be unique, will give you a unique y value, and there will be no overlapping of those at all. Okay, so that's what this says in this box. F of x1 will not equal f of x2 if x1 is not the same as x2. So two different x's must give me two different y's, is what that's saying. The way that you determine if a function is one-to-one is to use the horizontal line test. It works just like the vertical line test. You cannot hit the graph more than once with one horizontal line, and if you do, then that function is not one-to-one. So if I want to determine if these things are one-to-one, my suggestion would just be to graph them, especially if you don't know what they look like. Now, you should know what f of x equals 3x minus 2 looks like, but if you don't, graph it and then see, does it pass the horizontal line test? So if we graphed 3x minus 2, you should know that that's just a line, y-intercept of -2, slope of 3, and because we have a line, again, just think about if I were to draw vertical lines, am I ever going to hit this line more than once with a single horizontal line? And the answer is no. Therefore, this is one-to-one. X squared minus 4. Okay, if we did x squared minus 4, what we have here is a parabola centered -4. But again, if I draw a horizontal line, would it be possible that I hit that graph more than once with a single horizontal line? And the answer there is yes, and therefore this is not a one-to-one function. And then x cubed. This one's going to be a little bit tricky, but here's what x cubed looks like. And you might question what happens like right here at the x-axis, okay, at 0. If I draw a horizontal line, am I going to hit that more than once? And my recommendation would be to think about if you really zoomed in, what's happening here is it is increasing the entire time. It keeps on going up. It never goes strictly horizontal through there. So if you really zoom in on that, you can see that it's always going up, and therefore it would pass the horizontal line test. If I drew a horizontal line through at 0, it's actually only going to hit right here at 0, 0. It's not going to hit anywhere else. It's always increasing through there, and therefore this is also a one-to-one function. Okay, so again, the easiest way to tell if something's one-to-one is to graph it, or just know what the graph looks like and use that horizontal line test.